Hello children, welcome back to our physics class. In today's class, let us discuss in detail regarding the worksheet number 2 of electrostatics. So here we go from the first numerical. So first numerical is the law governing the force between electric charges is known as the force of repulsion or attraction between two charges is given by Coulomb's law, and it is equals to the force of attraction or repulsion between two charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them, as said by Coulomb's. Hence, the law governing the force between electric charges is known as Coulomb's law. Okay. Well, moving to the next question, when the distance between the charged particles is halved, distance between the charged particle is halved, the force between them becomes, children, as we know the formula for force as K times of Q1 Q2 by R square. So this is the given force. Now in order to find the new force, okay, so in the new force, the charge remains constant, proportionality constant is always constant. So what only changes is, for the second case, R2, so F1 is equals to F, which is equals to K times of Q1 Q2 by R square. So the second, for the second, when the distance is made half of the first value, then the new force F2 is equals to how much? So the value of F2 must be is equals to K remains constant, Q1 remains constant, Q2 remains constant. What changes means the value of R is now changed to R by 2 whole square. So let this be equation 1 and let this be equation 2. So dividing equation 2 with 1, let us see what happens. So equation 2 by equation 1 implies F2 upon F1, which is equals to K times of F2 value, let us consider Q1 Q2 by R by 2 whole square, whole by the value of F1 is taken as F, which is equals to K Q1 Q2 by R square. So simplifying further, we get this value as K gets cancelled, Q1 gets cancelled, Q2 also gets cancelled. Hence you are left with F2 upon, instead of F1, I can replace it with F, which is equals to R by 2 whole square is given by 1 by R square by 4, given by 1 by R square by 4. I'll write something like this, whole upon 1 by R square. So this is equals to 4 by R square into R square. So clearly F2 by F is found to be 4, or F2 is equals to 4 times of F. The value of F2 is found to be 4 times of F. Hence, the correct option is option D, that is 4 times of F. I hope the simplification is clear, children. Okay. So, if you want to make me understand clearly, I'll just simplify here. So, this is nothing but 1, nothing is there means 1 upon R by 2 whole square is R square by 4 whole divided by 1 by R square. So this can also be written as 1 by R square by 4 divided by 1 by R square. So divided by 1 by R square can also be written as multiplied by R square, reciprocal of 1 by R square. So division is multiplication. So this R square gets cancelled. Okay. So as a result, the 4 will come upwards. So F2 by F1 is equals to 4, or F2 is equals to 4 times of the value force. Hence it becomes 4 times. So now moving to the next question. there are two charges, 1 microcoulomb and 5 microcoulombs. The ratio of the forces acting on them means this is a mutual force of attraction. So, one charge is given and this charge is taken as plus 1 microcoulomb. This is one charge. And another charge is also there whose value is given as 5 microcoulomb. So, in the vicinity of 1 microcoulomb, there is a 5 microcoulomb. So, in the field generated by 1 microcoulomb, we are keeping this 5 microcoulomb. Okay. Similarly, in the vicinity of 5 microcoulomb, there is a charge that is 1 microcoulomb. So, in the field of 1 microcoulomb, 5 microcoulomb is being kept. So, it experiences some force. Similarly, in the field of 5 microcoulomb, 1 microcoulomb is there. So, it also experiences some force. Okay. That means, as we clearly know that the force, let us suppose that this is charge Q1 and this is charge Q2. Okay. Very clearly, the force exerted by charge Q1 on charge Q2 is equal and opposite to the force exerted by the charge Q2 and charge Q1. That is, force exerted by the first body and force exerted by the second body must be equal. But the direction of them will be in the opposite direction. This will be exerting force in this direction, whereas this will be exerting force in the other direction. But whatever be the case, the value of F1 is equals to K times of 1 into 5 upon some distance square, and here also K times of 5 into 1 upon the same distance square. So, the ratio, if you find it, then the ratio will be found to be 1:1. So, very clearly, the force exerted by first charge on second charge is equal and opposite to the force exerted by second charge on the first charge. Hence, the ratio is found to be 1:1. Hence, option B must be true. So, now moving to the next question, fourth one, a charge Q1 exerts some force on a second charge Q2. So, there are two charges given, one is Q1, the other is Q2. If the third charge Q3 is brought near, the force of Q1 exerted on Q2 will be. So, here what is given is a charge Q1 is there, second charge Q2 is there, and the third charge Q3 is also there. Okay, first of all, what they are saying is a charge Q1 exerts some force on the second charge Q2. And what is the force must be equals to? Some F is equals to K times of Q1, Q2 by that distance square, whatever the distance it is there, initially some R1 distance. If third charge Q3 is brought nearby, so somewhere charge is there, some Q3 is brought nearby, the force of Q1 exerted on Q2. So, Q1 is this. So, a small correction children, this should be kept as capital Q1 in order to remove the confusion. Then the force exerted Q1 on Q2 will decrease, increase, remains unchanged or increases if Q3 is of same sign or something. Well, so the force between these is equals to, say some distance F is equals to K times of Q1, Q3 upon that distance, whatever the distance you have considered. And similarly, between these two also some force exists, that is given as F is F1 or F2, let us consider something like K times of Q1, Q3 upon this distance, say R3 whole square. But the presence of the third charge does not affect the force between the first two charges. So, if you brought some more charge, means some forces might be acting between the other charges, but the presence of another charge will never affect the force experienced by the first two charges. So, what is the correct answer? Remains unchanged. So, what is the correct answer, children? Option C, that is, it does not affect the force experienced by the first two charges. Hence, the answer is remains uncharged. Okay, so let us move to the next question. Fifth one, important children. A total charge Q is broken into two parts. One is Q1, the other is Q2, and they are placed at a distance R from each other. Let us see. Let us try to visualize this. So, what is given? So, they have given you two charges, a total charge as Q, a total charge they have given it as Q. And this Q is broken into two parts, as they said. Two parts. One part is named as Q1 and other part is named as Q2. And these two, after separation, these two charges are placed at some distance. One is Q1, the other is Q2, placed at some distance given it as R from each other. The maximum force of repulsion between them, because they are from the same charge it is being made. So, no doubt they are like charges and some force of repulsion occur. You are asked to find the maximum force of repulsion. The maximum force of repulsion. So, clearly children, if you take Q1 as some Q, let us consider Q1 as some Q, then the value of Q2 must be equals to the total charge Q minus the small Q1. Q2 must be clearly from this Q1 plus Q2 is equals to total charge, or Q2 can be written as Q minus Q1. Q2 can be written as Q minus Q1. Okay, I'll write it like that only. So, one charge, the first charge, if you consider it as Q1, the second charge will be the total charge minus Q1. So, I just eliminated Q2. The second charge Q2 can be written as Q minus Q1. This is first charge and this is second charge. Now, the force between the two charges, the formula for force between the two charges is given by F is equals to K times of Q1, Q2 by distance square. Distance is R square. Or F can be written as K times of Q1. I kept it as Q1. But Q2, I replaced it with Q minus Q1 upon R square. Q minus Q1 upon R square. So, simplifying this further, we have F is equals to, multiplying this, we have K constant, distance of separation is also constant, Q1 into Q minus Q1 square. The value of F is found to be K by R square into Q1 into Q minus Q1 square. Got it? So, but what they are asking us means the maximum force of repulsion. In order to find the maximum force of repulsion, the formula related to this is we have to find the value of dF by dQ. If we find that dF by dQ equals to 0, then we get the value maximum. Condition for maxima. What is the condition for maxima? Condition for maxima is dF by dQ must be equals to 0. So, to find out so we have to take the derivative of F with respect to Q and you must equate it to 0 in order to get the maximum force of repulsion. So, let us try to find out the derivative of this. So, as we know that K by R square is constant, hence dF by dQ is equals to K by R square constant into with respect to dQ. So, Q1 is constant with respect to Q1. How much you are getting it as? Q1. So, derivative of Q1, Q by dQ, that is d by dQ of Q1 Q is nothing but Q1 times of dQ by dQ and this is equals to Q1. So, what is the final answer, children? The derivative of Q1 Q is Q1 minus, now we have to differentiate Q1 square with respect to Q. We have to differentiate Q1 square with respect to Q or Q1. Well, and this can be equated as, yes, with respect to the charge Q1, dQ1 must be equals to 0. So, this relation is 2Q1. Okay. So, dF by dQ1 is found to be, a small correction, this is not dQ, this must be dQ1, the smaller charge, not the total charge, smaller charge. Okay, so dF by dQ1 is found to be K by R square times of Q1 minus 2Q1. But as we said that dF by dQ1 must be equal to 0, so this value must be equals to 0. Bringing the K by R square to the right side, this will become 0 times of R square by K will become vanish. Hence, value of Q1 by minus 2Q1 is equals to 0, or the value of 2Q1 is found to be Q1. Bringing the minus 2Q1 other side, it will become plus 2Q1 and the leftover is Q1. Okay. So, based on that, yes, Q1 మిస్టేక్ వచ్చింది. అభిరామ్ ఇక్కడి నుంచి ఓకే కదా, ఆ ఫామ్లో చిన్న మిస్టేక్ వేసిన వల్ల. ఫస్ట్ నుంచి చెప్పడం బెటరా? సరే ఫస్ట్ నుంచి చెప్పేస్తా. దిస్ ఇస్ బెటర్, నేను ఎందుకు కన్ఫ్యూజ్ చేయడం. ఎస్, so moving to the next question, children. Question number 5. A charge Q is broken into two parts. One is Q1, the other is Q2, and they are placed at a distance R from each other. The maximum force of repulsion between them will occur when the given condition. So, what is given, children, according to our condition? So, they have given a charge and the total charge they gave it as Q1. And what they said was, this charge was broken into two pieces, okay, among which one charge they considered it as, the total charge is Q. Okay, the total charge they gave it as Q, and this Q is broken into two parts. One part is taken as Q1 and another part they considered it as Q2. And these charges Q1 and Q2 are again kept at some distance, say R. This is what they have given. A total charge Q is broken into two pieces, Q1 and Q2, and again these Q1 and Q2 are placed at a distance R from each other. The maximum force of repulsion between them will occur. Of course, because they are derived from the same charge, they will be like charges. So, no doubt like charges repel each other. Okay. So, the force of repulsion between them, in order to find out that, so first of all, let us see that, let us convert Q2 in terms of Q1. Clearly, we know that the first charge is directly taken as Q1. The first charge, this is your second charge. So, first charge, let us consider directly as Q1. Then the second charge would be the total charge is Q2. The second charge Q2 can also be written as the total charge Q minus Q1. Why? Because since Q1 plus Q2 equals to Q, Q2 can be written as Q minus Q1. So, Q2 can be written as Q minus Q1. So, now let us try to find out the force of repulsion between them. The force repulsion between any two charges is given as K times of product of the two charges. Formula is First charge is q1, second charge is q2 upon the square of the distance is r square, or F can be written as k times of, instead of q1 I considered it as q1, but instead of q2 I named it as q minus q1 upon r square. No doubt. So the force of repulsion between the two charges q1 and q2 are also written as k times of q1 times of q minus q1 by r square. But what they are asking us is to find the maximum force of repulsion. Condition for maximum force of repulsion, children, dF by dQ must be equals to 0. dF by dQ. What is dQ? So this is the total charge and this is the smaller charge we have considered. So with respect to the smaller charge, the derivative must be 0. Then only we'll get the condition for maximum force of repulsion. So we have to consider dF by dQ. That means d by dQ of the force. Formula for force is K Q1 Q minus Q1 upon R square. And this must be equated to 0. So multiplying this, we have derivative of, so K by R square can be taken common, times of Q1 into Q is Q1Q minus Q1 into Q1 is Q1 square. That's it. The other terms are taken out, equals to 0. So I already taken R square out, K out. So you are left with Q1 times of Q minus Q1. This is equals to Q1Q minus Q1 square, and that be equated to 0. So K by R square, if it is taken common, you are left with derivative of Q1Q minus Q1 square equals to 0. So K by R square, after taking to the right side, that will become R square by K into 0 will get vanished, 0. So derivative of Q1Q with respect to Q1 is, so here Q times of dQ1 by dQ1, that is equals to Q minus derivative of Q1 square with respect to Q1 is taken as 2Q1, which is equals to 0. So bringing this minus 2Q1 other side, minus 2Q1 is equals to Q, or Q1 is found to be Q by 2. If Q1 is found to be Q by 2, if Q1 is found to be Q by 2, then the value of Q2 must be equals to, so what is the value of Q2? Q2 must be equals to Q minus Q1, that is Q minus Q1 is Q by 2, or Q2 is equals to Q by 2. So what are the two charges, children? The two charges are Q1 and Q2. So first charge happens to be Q by 2 and second charge is also Q by 2. If the complete charge divided equally Q by 2 and Q by 2, then the maximum force of repulsion may occur between them. Hence, the correct option among them must be is Q1 equals to Q by 2 and Q2 also equals to Q by 2. Hence, fourth option must be true. Okay. Sixth one. Three charges 4Q, Q and Q are in a straight line in the position of 0, L by 2 and L respectively. So, let us picturize this. So, what is given means, here you have given three charges as shown in the figure. So, one is named as 4Q, the other is named as Q and one more is named as Q. And this is kept at origin. Well, and this is along x equals to 0, and here the distance is L by 2 and this distance is given as L. Okay. That means very clearly the distance between 4Q and Q is L by 2 minus 0, this is L by 2, and between Q and small q is L minus L by 2, this is equals to L by 2, and the distance between 4Q and the charge Q is L. So these are the three different distances between the first two charges, second two charges and first and third charge. The resultant force on Q will be, so this 4Q also exerts some force on small q. Capital Q also exerts some force on small q. So it asks you to find out the resultant force acting on the charge Q. In order to find out the resultant force, F net is equals to force due to between the two charges and also between, so for Q on Q as well as Q on Q. So this you are asked to find out, where the force experienced by 4Q on Q is given by charge force between these two, because finally the resultant force on Q are asked to find out. So on Q, 4Q exerts some force and that force is given as F1 is equals to K times of 4Q into Q upon the distance between them is L square. Similarly, force on Q due to capital Q. So, force exerted by Q on small q, let us name it as F2, which is equals to K times of the first charge Q, second charge small q, distance between them is L by 2 whole square. So, the net force is given by F net is equals to F1 plus F2, which you are asked to find out. So, in order to solve this, let us substitute the values and simplify. Okay, no, they are not asking us to find out F1 plus F2, children. Okay, and this F1 plus F2, they gave it as 0. Okay, the resultant force on Q will be 0. So, this is equated to 0. So, what is F1? F1 is taken as K, 4Q into Q is 4Q square upon L square plus F2 is taken as this value, which is equals to K capital Q small q upon L by 2 whole square is taken as L square by 4, which is equals to 0. So, taking further LCM, we have the 4 will come up, then this implies K times of 4Q square upon L square plus, again here 4 will go up, 4K capital Q small q by L square equals to 0. LCM, you have L square. So, L square when taken to the other side, that will become 0. Then this implies we have 4K Q square plus here also 4K capital Q small q equals to 0. Together we have 4K as common, left over is Q square plus capital Q small q equals to 0. 4K taken to the other side, this will become 0 by 4K equals to 0, or Q square plus QQ is equals to 0. Hence, as you are asked to find out capital Q, leaving this term the other side, taking minus Q square to the other, then we have QQ is equals to minus Q square, 1 Q will get cancelled. Hence, the value of Q is found to be, how much, children? The value of Q is found to be minus Q. So, this is your answer. The value of Q is found to be minus Q. Hence, first option must be true. The value of Q is found to be minus Q. Got it? Well, shall we move to the next one? So, moving to the next one, 7th question. An isolated solid metal sphere. A sphere is given, isolated metallic sphere is there. Okay, given positive charge Q. So, a sphere, on this sphere, so what it was given is positive charge Q is being given. Okay, some positive charge Q is given. The charge will be distributed on the sphere uniformly but only on the surface. Only on the surface but non-uniformly. Uniformly inside the volume, non-uniformly. So, as I already told you that charge will always reside on the outer surface of the sphere. Outer surface of the metallic sphere. So, charge will never lie inside the sphere. It only occupies the outer space. Now, it was asked whether it is distributed uniformly over the surface or non-uniformly. No doubt, the charge is always distributed uniformly on the surface. Hence, the first option must be true. Simple. Moving to the next question, 8th one. Two electrons are separated by a distance of 1 angstrom units. What is the distance of separation given, children? 1 angstrom units. So, the distance of separation is given as 1 angstrom units, which implies 1 into 10 power minus 10 meters. What is the Coulomb force between them? So, how many electrons they gave? 2 electrons. And the charge of each electron is Q1 is equals to Ne. We know the formula Q is equals to Ne, number of electrons. So, this implies the charge on each electron is given by 1 into 1.6. Number of electrons is 1. Charge on electron is 1.6 into 10 power minus 19 coulombs. So, like that you have 2 charges, 2 electrons. And the separation distance is given as 1 into 10 power minus 10. So, using all those formulas, you are asked to find out the force. So, the value of force is formula is K times of Q1 Q2 by R square. The value of K is 9 into 10 power 9. And the value of Q1 is first electron, it's equals to 1.6 into 10 power minus 19. Q2, second electron, it is also equals to 1.6 into 10 power minus 19 whole upon the distance of separation is given as 1 into 10 power minus 10 meters. So, if you simplify this properly, you will get the amount of force acting between the 2 electrons. So, simplifying this, we carefully will get the value of F as 1.6 into 1.6 is 2.56 multiplied by 10 power 9 and minus 19 is 10 power minus 10. So, this 10 power minus 10 and below 10 power minus 10 will get cancelled. Okay. So, plus 9 minus 19 is minus 10. Minus 10 minus 10 gets cancelled. Hence, you are left with 10 power minus 19. Okay, children. So, simplifying this further. Yes, the distance is given as 1 angstrom, which is equals to 1 into 10 power minus 10. So, distance R or D, whatever be the case, distance D is nothing but R, but here we have to find out the value of R square. R square means 1 into 10 power minus 10 whole square. R square means 1 into 10 power minus 10 whole square. So, instead of that, let me write this as 1 into 10 power minus 10 R square. So, R into R. 1 into 10 power minus 10 into 1 power 10 minus 10. So, this totally cancel. 9 and minus 19 is minus 10 and here also minus 10 overall gets cancelled. So, you are left with 9 times of 1.6 into 1.6 is 2.56. Above you have 10 power minus 19 and below you have 10 power minus 10. So, simplifying further, how much are we getting, children? Just simplify these two to get the proper answer. So, we have finally the value of F as 9 multiplied by 2.56. So, 54, 50, 23. Okay. So, 23.04 multiplied by 10 power minus 10 and minus 19, you are left with minus 9. That's it. Hence, F can also be written as decimal if you take it below 2.304 times of 10 power minus 8. One decimal is removed, so I reduced this. Or F is approximately equals to 2.3 into 10 power minus 8 Newton. Force is given as 2.3 into 10 power minus 8 Newton. Hence, the correct option is option 1. Okay. Moving to the next question, ninth one. The ratio of the forces between two small spheres with constant charge in air in a medium. So, two conditions is there. First condition, it was given in air, and the second condition, it is given in medium, and dielectric constant is K. So, you are asked to find the ratio of the two forces. So, earlier we said that if epsilon naught in air, if you consider the value as epsilon naught, and in medium you have to consider this as Em, which is equals to K times of epsilon naught, where K is the dielectric constant, So, substituting here, we have the value F1 is equals to 1 by 4 pi epsilon naught. Two charges, okay, two charges Q1, Q2 will consider upon R square. And F2 must be equals to 1 by 4 pi epsilon M Q1, Q2 by R square. Okay, epsilon naught, epsilon M. That's it. And we know that the value of epsilon M is equals to K times of epsilon. Let me write it clearly. K times of epsilon naught, where K is called the dielectric constant. K is called as dielectric constant. So, you are asked to find the, so one in air, this is in air, and this is in medium. So, medium we replace with Em, and this is with epsilon naught. We are asked to find the ratios between the air to the medium, that is F1 upon F2 is equals to, F1 is 1 by 4 pi epsilon naught Q1 Q2 by R square whole upon 1 by 4 pi epsilon naught. So, instead of whole upon, let me write it as multiplied. Reciprocal of that. Reciprocal of this is 4 pi epsilon naught M by 1 times of, reciprocal of this is R square upon Q1, Q2. Simplifying this, we have, so Q1, Q2 gets cancelled, 4 pi also gets cancelled, R square also gets cancelled. Hence, you are left with, so F1 by F2, the ratio of the forces is given as, numerator you are left with epsilon M, and denominator you are left with epsilon naught. But epsilon M is nothing but K times of epsilon naught whole upon epsilon naught. So, this epsilon naught gets cancelled, and hence the value is this K upon 1. Hence, the forces, the ratio of the forces when kept in air to the medium is found to be K is to 1. So, the correct option must be option B, that is K is to 1. Okay, children. So, now let us move to the next question, that is question number 10. 4 charges are arranged at the corners of a square A, B, C, D as shown in the figure. The force on the charge kept at the center O. So, you are asked to find at center O, some charge is being kept, and you are asked to find out the force on this charge kept over there. In order to find that, let us discuss in detail. Clearly, we know that, observe A children, at A what do you observe? Plus Q is there, and even at C plus Q is there. So, what happens means, this charge tries to push the positive charge other side. If you consider this as a positive charge, the positive and positive repel each other and it pushes this charge the other side. Similarly, this plus Q charge located at A tries to push the unit positive charge or charge Q naught at this point to the other side. So these two charges exert equal and opposite forces on the charge Q. If this happens to be 5 coulomb, this is also, 5 Newton, here also 5 Newton, but in the opposite direction and hence gets cancelled. So, A and C, the charges located at A and C exerts equal and opposite forces on each other. Hence, the net force will along the line AC will be 0. So, there is no effect on this C. Now, the leftover is minus 2Q at D and plus 2Q at D. As we have considered a positive charge at this point, say Q naught, clearly this minus 2Q due to attraction tries to pull this charge Q naught this side. Similarly, the positive charge 2Q pushes the charge Q naught again in this direction. As a result, the charge Q naught has a tendency to move towards the corner D. That means the Q naught will be moved in the direction of D and hence acts along BD. Acts along BD. Okay. So, is it 0? Is it along the diagonal AC, along the diagonal BD or perpendicular to the side AB? No doubt, this force acts along the line BD and hence the correct option must be option C, that is along the diagonal BD. Clear?